So I work at a company called Sycamore Informatics. We do a lot of enterprise-y apps, and we have a lot of stuff like this where you have master detail. You select an object and you see its properties on the right, and you can validate and update that object. You may notice the chyron over on the left for the selected object. So since we have so many of these editing operations, we decided to use JSON schema to define the shape of our data. And that's enough to do validation and build UI from. And an example would be this. So this data structure says we've got a form which has a name property, which is a string, and also which is required. A repeating, which is a Boolean, and required, which is another Boolean, which is defaults to true. And then since it's just a data structure, you can throw whatever you want in there. So we have our own REST endpoints in there. So that's what I'm going to be consuming to create and update records. So users complained that this was tedious because you have to select an object, start editing, edit the field, and then save it. It's 4 steps. So every object is vertical. It uses a lot of screen real estate, wastes a lot of pixels. So people wanted a high volume editing experience with horizontal records. So spreadsheets are great for tabular data, even if you don't use formulas. And people love to create ad hoc databases of everything in a spreadsheet. And everyone knows the keyboard shortcuts to move around, begin editing, all that good stuff. So it's the principle of least astonishment. Everyone knows, spreadsheet keyboard shortcuts. They're sort of baked into people's expectations. So the great thing in doing this was everybody knew how spreadsheets work. So if there was ever a design question, you just say, well, Google Sheets does this, and boom, end of discussion, which is just great. You never get that anyways, usually. So what we've got here is that each column is defined by the JSON schema. So you know its data type, you know its label, you know its validation. You can edit existing rows or create new ones, and it will save the records up to the server as long as they're valid. And it's extremely space efficient. It's hard to think. You could tighten up the margins, but it's very dense. And the other interesting thing is that with spreadsheets, people expect autosave. They expect not to be clicking a save button. So that's what I built, is this high volume editing spreadsheet. So a couple demos, and I want to emphasize how dynamic this is. First, on the top, you can see there's a filter bar where we can filter the records based on criteria. If we turn on this debugging stuff, these are the criteria that the records match. This is entirely client-side data. So the rows are dynamic based on criteria. It's not just hard-coded. Another thing we did is custom actions. So here we have the button on the left is to toggle a soft delete, and custom markup on the row, showing if it's deleted or not. It's dynamic horizontally. Columns can be locked. And you can see this jank over on the left that we're doing scroll listening and z-index hacking to get those columns to stay on top of the other ones, which is something we were able to do away with react-virtualized. So it's dynamic horizontally and vertically. So this app was already using Redux, but I wanted to investigate MobX because I felt like each grid should manage its own data, that it was logical, that the object should live within the grid, not be global, because who cares about some in-process object within the grid? So this was my first time using MobX, so I watched the Egghead video on it, which is about 30 minutes. It's very quick. And I was concerned about performance. If you have hundreds of rows and each row can be validated, you want to be able to memoize those results. You don't want to do work twice. And you don't want to do extra work to not do work. So that's what MobX gives you. The mental model of MobX is a spreadsheet. You define some data, you define derivations, or there could be views which read from that data. And then when the underlying data changes, this engine, which is MobX, or the spreadsheet, understands the connections to the data and updates wherever that data is consumed. So it's transparent reactive programming. So that's the model for MobX. And the gist is basically what I just said. Define your state, make it observable, create a view that responds to changes, and then modify the state. By law, I have to show a to-do example right now. So, so here it is. I think this is like 80 lines of code, perhaps. So we can see that we've got observable data. We've just got observable decorators on the fields in that class. You don't have to use decorators, but if you have them set up in Babel, it's a nice way to do it. You'll also note there that get unfinished count is computed. That's a computed expression. So that's our observable data. Oh, here's a more readable version of the same thing with what I just said. And then views read the state. So the view is an observer of that data. And then in our mapping function, we're passing down the to-do, and we're just reading it. We're reading the IDs, whether it's finished, the label, all that good stuff. And the fantastic thing about MobX is that just like in a spreadsheet, that the act of reading the data subscribes you to it, so that when that data changes, you'll be notified and you'll update. So you're never stale. So next, we modify the state when you click on the checkbox. You can see down the bottom in the on-click handler, it's just directly toggling the finished Boolean. So you might be thinking, are we directly writing to data? Is this like Angular 1 or what's going on? I thought we weren't doing that anymore. So the answer is there's this thing called strict mode in MobX where if you opt into strict mode, unfortunately it's opt-in, not opt-out. If you opt into strict mode, you can only mutate data within actions. It forces you to put everything in an action. So you get this error message, changing values outside of actions is not allowed. So if you use MobX, I highly recommend using strict mode from the start. So to add the action, we import it from MobX. So there's our error. So we'll import action from MobX, we'll make a new function and then decorate it with @action, which means that it's allowed to mutate the data. So it's a runtime error, which is another reason to have it in strict mode from the beginning, because you don't want to be getting runtime errors. But the end result, once you define these actions, is you get controlled mutations through an API. It's not global mutable data, which opens the door to bugs. So you have the same result as Redux of you're only doing changes that you've decided ahead of time to make actions for. Okay. Derivations. I'm going to try to jump into a little bit of demo. By the way, has anyone seen this site called I think it's called codeandsandbox.io? This site? It's really, really good. So here's our code, and in our get unfinished to-do count, which is computed, we've got it logging every time that it recalculates the remaining count. So every time I toggle it, it calls that method. So if the to-dos change, then this guy gets re-rendered. Does that make sense? Okay. So we can prove that this is lazy by taking out the call to get unfinished to-do count. We'll reload it. And now when we check items on and off, it doesn't recalculate it. So it's lazy. It's only doing this work on demand. It's not doing extra work. And conversely, if we show the unfinished count, 800 times, it should only recalculate it once because it should memoize the results. And this is transparent memoization. You don't have to do anything special. It's just that your computations are pure functions. They're returning data, so they computed should have no side effects. They're pure functions. So I hope I've shown that derivations are cached and they're lazy. Okay. Have I covered the gist of MobX, I'm probably going way too fast.
Could you show how you pass the props down?
Sure. So down below, we create a new to-do list. We add the tasks, and then we pass it in as a prop. So to-do list view gets to-do list. And then the to-do list view, there's our store. So then we map over the to-dos. Then we pass each one down to the stateless function. So the only trick is to wrap your views in observer and to wrap your data in observable. That's basically the whole thing. Other questions while I'm in here? Okay. So MobX gives you transparent reactive programming, observable observer. It tracks your dependencies, and the act of reading it subscribes you to it. And it memoizes the results. So if we sort of compare Redux and MobX, Redux is more or less a global. You put all your eggs in one basket and you guard access to it very tightly. MobX really doesn't care how you get access to your data, just somehow it's a variable that you can read. Redux wants you to have foreign keys, normalized, that should be normalized. And then with MobX, it's direct containment. Redux is pretty high boilerplate. MobX is none, I would say. But conversely, boilerplate or magic. Pick your poison. So I think keep your data as local as possible. Not everything should be a global. Having data be global is bad, no matter what century it is. It's just bad. So in my opinion, don't move it high if it doesn't need to be. If it needs to be like your username or your roles, great. But it doesn't, only if it has to be. So looking at some code, the action of locking the columns was basically where the red arrow is. We're pushing it onto the locked columns. And then down below, this visible columns in order is computed. And it does all the dynamic behavior of combining these columns together. So this is what you basically end up with. Pure computed functions, and then actions which mutate the data. And I'm a big TDD fan, so I started out with a TDD approach. And the really great thing about MobX is if you trust this connection between the data and the view, you can manipulate the data and trust the view will stay in sync. You don't have to test that binding between the two. So you can just do simple unit tests. So validated objects represents a row in the database. You pass in the schema and then the values for it. It socks away the schema, and then it tracks the last change time and its values, and then setting it updates the hash and then the change time. Really simple. So a test would be create a new one, assert that the change time is 0, mutate it, the change time should have bumped. So when I was writing this, I just did lots and lots of code like that, really simple model manipulations. Here, this is where we actually do the JSON schema validation. Oops, sorry, wrong slide. Here's where we actually validate the object. So we have a validate schema method, and then Twojsi is an expensive operation because it converts it to a JavaScript hash. So this is computed, meaning that it will memoize the results of the check, because otherwise it could be quite expensive. So you create a new object. It should not pass schema validation because it's missing a field. We give it the required field. It should now pass schema validation. And it passes schema validation if the errors are empty. So you want to stack pure functions on top of pure functions, express a concept once, keep it as dry as possible. So it's, if you were around during OO days and think in object-oriented terms, it feels very familiar and comfortable. Some performance tips. You should only observe data that changes. So observing data is a cost overhead, so don't observe static data. And you observe the data that does change. Twojsi, I sort of already mentioned, is slow. We have really complex custom cell renderers, and we're getting terrible performance. Once we got rid of the 2JS calls, we were 13 times faster. It was less than a second.
Where's 2JS used? Is that part of immutable?
No. Well, it's analogous to the concept in immutable. It's like I've got this fancy data structure, which is like an object, but with my extra behavior. And 2JS is create a vanilla JavaScript object literal out of it, which is allocating new memory. Yeah, same concept. Okay, the dev tools. So there are these dev tools you can install and then inject onto the page. It gives you a lot of functionality, or there's a Chrome extension to do the same thing, which I just recently found, and it's fantastic. So you can bring up the Chrome extension, turn on this logging, and it will tell you every time something re-renders, how many times it's re-rendered, and the count, the render time count. It's sort of useful. Another thing is you can point to an object on the screen, and it will tell you what data it depends on. So this column header is reading widths, and then the column labels. Initially, I used that a lot, but now I don't use it at all because I trust and it just works. But the really interesting thing, in my opinion, is logging, where you can log actions. So as I'm moving around in the grid, it's logging my actions and their parameters, and it's a nested log. And you can see the arguments and even who called that action. So once you expand the stack crawl, you can see where an action was invoked. And then this is kind of interesting because this is my key handler where it's looking at all the key codes of did you arrow left, right, up, down. So it's basically just looking at the code and then calling the appropriate method on the underlying grid state. So the outer React component is just delegating down into the MobX data structure. Beware denormalizing by hand. I had a bug where I decided it would be a good idea to put an isSelected property onto the row structure, and I got this bug where 2 rows were selected. Even though I was really careful to turn it off on the old row and turn it on onto the new row, I still got this bug where I ended up with 2 rows being selected at the same time. So trying to write optimization code by hand is error prone, and MobX can do that for you. So let it do what it's good at. Don't hand cache things. So in summary, I love MobX because it's low boilerplates and intuitive programming style. You get the memoization and performance out of the box. It's predictable and synchronous. Nothing is asynchronous. Whenever you call it a computed method, it's never stale. And things aren't, it's not like promises where you have to solve time puzzles. You know, everything is synchronous and you can count on it. So it's very simple. Actions I would absolutely recommend. And I've been, adding to this code for like over 6 months, and it just keeps scaling and performing very well. It's very, very stable. Yep. That's the bottom line. So if you're interested, you Google Egghead MobX. There's a 30-minute course by the creator, which is really good, goes through all the concepts. Another fantastic resource is if you go to codeandsandbox.io, they have all these examples. They're basically searchable fiddles. So you'll find 700 examples of MobX, but you can also look for lots of other stuff, React Router, React Motion, whatever you want. So Code and Sandbox is pretty sweet. Okay, is it web scale? We tested it. We wanted to test, initially we were going at about around 500 rows, but we needed at least 5,000, which is pretty low. It's just to a lot of people, not to us, luckily, so far. And it just fell over because we were creating all those DOM elements. So 5,000 times 10 columns, and there's probably 10 DOM elements for each cell. So it's just hundreds of thousands. And didn't work. So we needed virtualization. So we needed to have variable height rows, depending on the data. We wanted to have the locked columns and rows, but not as janky, hopefully. We wanted to be able to handle thousands of rows. So with react-virtualized, you only create the elements that are on screen. So down in the elements, you can see it's only got a few divs, even though this is hundreds of thousands of rows. And then it uses inline styles to reposition things. And there are lots of different versions of things depending on your needs. Like here we really needed the locked headers and columns and the different row height. But if you go on react-virtualized.com, he's got a wizard of like, I need this, but not this, but not this. You should use this component. And this is done by Brian Bond, who's on the React core team now. So multi-grid gives you this behavior where it's really rock solid when you're scrolling around. So it's basically every quadrant is its own grid, so it's quite stable. And in terms of code, like this is a fully functional multi-grid example. You supply this cell render function, and it comes in with a key for the cell, the inline style, which has like your top changing around, and your basically your X and your Y. Then you return the markup for that cell. And for about a day, I thought I would try to write this myself. No, this is very good code, and the Jest test suite is just a thing of beauty. If you ever want to understand how the code works, just go into the Jest tests, and they're fantastic. So this cell render function, it comes in and it gives you an X and a Y, basically the row index and the column index, and you decide what to render. So to get the MobX tracking, I turn around and instantiate a grid cell and pass all those properties in. And this is pretty weird style because you switch on the X and the Y. You're like, if I'm in the header row, I do this. If I'm else, I do this. If I'm at this X position, then I do this. So it's pretty weird, not great code, but that's kind of what you have to do to be free of, the constraints of a grid. So previously, the structure was your sort of typical top-down, left-to-right decomposition. So you'd have rows, each row has the cells, and it marches top-down, left-to-right. Afterwards, we have the grid has a cell measurer and a cell, because things are virtualized horizontally as well. There's no concept of a row here anymore. It's just cells with XY coordinates. And most of the code in the test stayed the same because the logic was in the MobX, but we had a lot of styling changes, kept the designer busy, getting everything working. One gotcha is once you're looking through a keyhole and you're only rendering what you see, you can't use the browser find because it's not there. So you have to roll your own find. You have to understand how the data structures map to what's on screen and sort of do that twice, both in your rendering and in your find function. It's kind of a pain, but it's the price of admission. So that's what Google Spreadsheets does, is that they capture Command F themselves. So in summary, both of these libraries are fantastic, and I would highly recommend them. MobX, I think, is a strong contender for daily use. I think if data doesn't need to be global, don't make it global. React-virtualized, it's sort of like, if it gets big enough, you may need it one of these days, but not until then. Okay. Questions? Sure.
How does React-virtualized compare with React Lazy and libraries like,
I'm not super familiar.
We're looking at some of them, I was wondering.
Okay. I mean, I feel like a large part of it, of course you'd look at GitHub stars and things like that, but I feel like the reputation of the committer being on the React core team and how optimized it is went a long way. Yeah, I don't know. I can't really speak to that. Love to hear if you find something, if you end up with something other than virtualized.
Actually, related to his question, sorry to cut in.
Yeah, sure.
Just to add to his question, because we're both working on the same team, I got all excited there when you were saying that. That is, what about if, in other words, do you get a payoff if you got the data set that's not particularly huge? Let's say you have 100 things, right?
Right.
And you just want, and you have a window of like 5 or 6 visible ones, and you want to like just render what's in the window. Is something like this overkill, or is it also useful for something like that, where it's not a huge amount of data?
I would think unless you're on a phone or something where you're really memory constrained, it sounds like overkill.
Okay.
That's my first impression.
You tried pressure testing how large data set, how many rows storage versus the cycle review that's inside the layer here?
Right. Well, I mean, you're definitely going to run out of memory at some point, completely independent of DOM rendering.
Right.
And that's just math.
But you haven't done tests yourself?
No.
Beyond your 5,000?
Yeah, no. 5,000 so far for this part of the app seems to be an upper bound. I mean, at some point we're going to need to introduce paging and be smarter about things, and you can't just say, keep it all on the client. Ricky?
I
Did
was
you?
wondering if you run into any issues with like accessibility, any issue of user screen.
I'm not aware of any. I mean, I'm not sure if we're super good about that. I don't know if QA tests for that. Can't say.
You mentioned MobX is sort of higher magic. Is there any points you've seen the magic unravel, like computed inside a computed or something like that?
Right. The only times it hasn't done what I expected is when I forgot to wrap a view in an observer. That was it. Yeah, it's really good.
So just to understand, at which point does the validation happen? So you
Right.
go out of a cell, you validate the whole row, which represents an entity according to the schema, right?
Right. It's keystroke by keystroke. So, yeah.
So it's updating, it's persisting it essentially by keystroke?
Well, it's not persisting it. So locally, if you have an empty field which is required and it's outlined in red and you type A, it updates that field to A, which updates the values, and the validations is watching the values hash. And then the cell is watching the validation errors to know if it should put the red cell in there.
Okay.
So it recalculates the validation errors. They're now empty. The cell observes it and goes, oh, I no longer have this red border. And then it only pushes it up to the server at the point where you're no longer actively editing, and the object is valid.
Okay. How do you handle more complex validation rules, like a person cannot appear twice in the table, for example, the same person?
Yeah. So you're basically talking about server validation, right?
Well, if there is no server and you just have this
Right.
information in the browser.
Yeah. So far, we've been able to get away with just what JSON schema gives for us. But then, I mean, server side, you could run into that type of issue. So then you get server validation errors down, and you have to merge those two together to say, that name has been taken server side.
So how do you deal with sorting? Is that all done server side, all of the information that you
Right.
can send it as pieces, or?
Yeah. There can be an initial sort on the server, but then also client side, we're going to have multi-column sort. And then in terms of the model, what Google Sheets does is once you sort something, you've sorted those rows, and that's a one-time operation. Because then if you were editing a cell, you wouldn't want it to jump around in the order based on the sort. So I think there's a real difference in expectations between an editable grid, where things better damn well stay where you put them, or else you won't like it, versus a read-only grid where you expect the sort order to be maintained. I think one more question, and then I'll be happy to take them later, and we can schmooze. Go
Have
ahead.
you played around with Twojsi?
No.
Okay. It's a library that you can use with Redux. Different parts of your store can be taken, and as any of those change, it sort of memorizes that and passes it down as props.
Yeah.
And you can get similar things to MobX when you just have the Redux world without generating MobX.
Right. I really like the fluency of the MobX model,
Right.
of pure functions and computations, and absolutely not thinking about the derivation chain and what gets memoized. And unless you really screw up, it's hard to get bad performance for this, which I've really screwed up before. But generally, you don't think about perf, and the memoization just happens for you. Okay. So one more question. Okay, go ahead.
One big difference between Redux and MobX is about like decentralized or centralized client-side state. So what should we think about the advantage of decentralized state?
Right.
I would say like if we centralize the state like by Redux or something, it's more like data flow was more convenient.
Yeah. Well, it's kind of paradoxical because I actually feel like on really, really big apps that Redux tends to get bad because you have all this global data that if you have 800 screens, you don't want to have 800 reducers. That's bad. Just to take things to their logical conclusion. Okay. So I think I'll cut it there, and then I'll be around for questions. And feel free to hang out and drink beer and eat pizza. Thanks.